Okay, so x squared minus 1, you can split it. X minus 1, x plus 1. Now, you have a numerator here. So you have to decide what the numerator should be. Firstly, we have to look into two things, right? The x power of the numerator, the x max power of the denominator. Okay. So now denominator x power is greater than numerator power. If that happens, you are not going to do anything to the front here. That means you are going to put 0. Okay. You are going to put 0 if the denominator is greater than the numerator. Then again, if that happens, again you look into the right hand side. Right hand side, the first term, x to the power 1 here, right? If x to the power 1 is what you have in the denominator, you construct a term which is 1 power less. Understand? 1 power less. Okay. So that is it. Then the next term, b, the maximum power is 1 here. So you have to construct something 1 power less. So essentially, when you write this one, this is nothing but a x minus 1 plus b x plus, right? And then you do the cross multiplication and find a and b accordingly. So once you have this structure, finding a and b is very easy. Okay. I will go to the second one and see. In the second one, the numerator, the highest power is 1. Denominator highest power is 2. So x1, x2, right? Highest power. So now 2 greater than 1. So that means you are going to put 0 here. If that happens, you are going to put 0 here. Then you will look into this here 1. So you construct something which is 1 power less. So it's going to be again a. 1, again b. So actually it should be a x 0, b x 0, right? But that would be 1. So it's going to be again a divided by x minus 1 plus b divided by x plus 1. Okay, so the next one. Now you have 2 here. Denominator also 2 here. So now 2 is equal to 2, right? Now, if that happens, you are going to add a constant here. Okay, there is a structure. So follow the structure. If those are equal, you make a constant here, right? Actually, constant means what you are going to do is, this is what actually happening. Okay, look at this. 2 minus 2 is 0, right? Right. So you are going to put x to the power 0 power here. Okay. Plus, here you write x minus 1 plus x plus 1. So again, b and a is coming here. Right. So this can be written as k plus a divided by x minus 1 plus b divided by x plus 1. Now do the same thing to the other one. So here 3 greater than 2, right? If 3 is greater than 2, what you do? Now the highest power is 1, right? So it's going to be k x1. Why? Because the difference is 1, right? You can see difference is 1. Then plus, okay, 1 second. Plus, so you have x minus 1 here. So it's a here b x minus 1, right? X plus 1. So this is fine. But here, importantly, you have to put, this is k1, k2, x to the power 0 as well. Because if you start from 1, you have to end it by the lowest power 0. Okay. So rhythmically, we will understand it. So see, this is the lowest power. So then you don't have any problem there. X k2 plus a divided by x minus 1 plus b divided by x plus 1. What about this one? So you can see now 4 minus 2, right? 4 greater than 2. 4 minus 2 is 2. So what do you do? K1 x, right? K1 x2 plus K2 x1 plus K3 x0. So if you start from 1, you have to end it by the 0 value here, and then plus a divided by x minus 1 plus b divided by x plus 1. Right? So the answer would be for that one, K1 x squared plus K2 x plus K3 plus a divided by x minus 1 plus b divided by x plus 1. Now you can see we are dividing a fraction. We are writing a fraction in many terms, right? Okay, the next one. Here x0, here x2. Yeah. So 0 is greater than 2. I mean, 0 is less than 2. Right? So now what to do? Now what to do? Can you write that in partial fractions here, guys? Can you write this one like x minus 1, x plus 1 or something?
No, sir.
No, you can't, right? You can't write it because it doesn't make sense. That's why this structure is given in base case. Tan inverse, right? You can't break the denominator. That's why the mathematicians know that you can't break. So that's why this is included in the base case. So then you can directly use it. So if you have that, you don't have to do anything. Okay. What about this one? Can you use any base case? No base case, right? No base case here. So then how to do that? Guys, speak up.
Sir.
Yeah.
Well, if you were to integrate it, you would use substitution.
You can use substitution, yes. Substitution. Right. Or observation. Why I'm saying observation? Do you remember I told you this? If you have fx here and f dash x is on top, so answer would be log e fx. Can you see the derivative of this one is here? It's 2x, right? So it's here. So you introduce 2 here, you put half here there when you do integration. Understand what I'm saying, guys? Okay. Okay, so do this one for me. Okay, do this one for me. Okay, do that. Okay, so now we'll go for another example. If I have 1 divided by x minus 1 squared is not example, actually, this is a theory. So if you have that, you write this one. This is a special theory, okay? This is important. If you have the structure, the whole thing squared, you break it, a divided by x minus 1 plus b divided by x minus 1 squared. There is a special structure. So you put a here, you have to put 0 here. Why? Because here the numerator power is 0, the denominator power is 2, right? So 2 is greater than 0, so you are not going to put any constant there. Now, for example, if you have x divided by x minus 1 squared, then still you can see it's 1 here, so no problem, you can go with this. So a divided by x minus 1 plus b divided by x minus 1 squared. Okay, and then if you have x squared divided by x minus 1 squared, right? If you have something this to integrate like this in integration, so no base case, no substitution is working, right? So then you have to take this one, x squared divided by x minus 1 squared. Then you know the partial fraction business. There you can see this is 2 here and 2 here equal, right? So then you have to use a constant here, plus then a divided by x minus 1 plus b divided by x minus 1 squared. And then again, if you have x3 x minus 1 squared, so then you can see here 3 is greater than this, then you use k1x, right, plus k2, because the difference is 1, plus a divided by x1 x minus 1 plus b divided by x minus 1 squared. Same structure, okay, same structure is coming up here. Okay. Okay. Any questions so far? So I'm sort of done with partial fractions. Then we'll discuss few questions here. So I wanted to teach you partial fraction in one shot. Okay. I didn't want to dance around, right? So this is a big topic, but this is the essential logic that you have to understand. It's very hard to give a note on this. Why? Because math is something you have to understand, right? So you have to understand the logic. Okay. So everyone do this question now. So if you have, let's see. Let me construct the denominator first. Okay, this one. What you're going to have there?
Yes, first day.
Yeah. So now there you have to see 2 is here, right? So I told you, whenever you write the numerator, you have to use 1 power less. So here it's ax0, bx0. So this should be cx plus d, right? So it's a good question. So if you can do this question, you understand everything. So if you have something like this, then you break the fraction into 3 fractions now, and then you can find A, B, C, D by comparing the coefficients. But what you do is, end of the day, you just integrate this only. It's like that. So once you know A, B, C, D, game is over. Okay, so once you know A, B, C, D, game is over. So now I want you to do this question actually. Do this integration. Okay, so let me do that first. So now I need to find A, B, C, D. So what I will do the cross multiplications, right? So when I do the cross multiplications, I get 1 divided by x squared plus 1 squared minus 4. So you can do that partial fraction calculation separately. So A, what you are going to do is you are going to multiply by x plus 1 and you are going to multiply by x squared plus 3. Plus B should be multiplied with x minus 1 and x squared plus 3. This is common denominator, right? Plus cx plus d, you have to multiply that with x squared minus 1. So x squared minus 1 is x minus 1 x plus 1, right? So if you don't do 1 hour work every day, you don't have the rhythmic work. So it's that. So you do this. Then you have to collect terms, right? So how do you collect terms? Look. Now x, right? Sorry, x cube, right? So x cube, what are the coefficients now? So you don't have to expand it. If you expand this, it will take 30 minutes, right? So you observe. Okay. So you have to do it intelligently. So here you can see x and x squared gives you x cube. So then you have a along with that. And then here x and x squared is going to give you b. So b is going to give b is the coefficient. Now here c and x squared, cx and x squared gives you x cube and c should be here. So likewise, you can find the coefficients. So x squared coefficients. So x squared coefficients would be, okay, let me see, a. So I'm going to do it. Here we get minus b. Here we get plus d. Okay. So correct me if I. So x would be 3a. Hold on. Yeah, 3a. Then we have 3b. Then we have minus d. Then constants, right? X to the power 0 terms, constants. So what are the constants you have? 3a. Okay. And then you have minus 3b. Then you have minus. Okay. So now here you have 0x3 plus 0x2 plus 0x plus 1x0, right? So that means this whole thing is 0. This whole thing is 0. This whole thing is again 0. Part is going to be 1. You can see I'm doing it in one line, right? So you have to develop your skill to do it. You have a 2-hour paper, not a 2-year paper, right? So just do it. Do it faster than me. Okay. So, okay. Okay, can you find me ABCDs, please? Tell me ABCD values.
A is 1 divided by 12. B is -1/6.
-1/6.
C is 1 divided by 12 as well.
D.
-1 divided by 4.
Okay. Okay. So now the game is over, right? So you can write this integration. A is 1 divided by 12. So I'm going to take 1 divided by 12 out. So 1 divided by x minus 1 then plus b is minus, right? So it's going to be 1 divided by 6 integration 1 divided by x plus 1 dx, then plus c is what? C is 1 divided by 12. D is 1 divided by 4. So if I take 1 divided by 12 out, so it's going to be x. So minus 3, yeah? Divided by x squared plus 3. So I hope you understand what I'm saying here, right? So I hope you understand what I do this, why I do this one, because once you multiply, you get the right value back. Then this is going to be 1 divided by 12. This is log e x minus 1 plus minus 1 divided by 6. This is going to be log e x plus 1. Then then again plus 1 divided by 12. So this structure, so look at this structure. This structure is like this, right? Integration like f dash and fx, right? Right, dx, right? So, but before you go into that, I'm going to split it, but because x minus, right? So integration x divided by x squared plus 3 dx separately minus 3. Okay, I'm going to put 3 outside. 1 divided by x squared plus 3 dx here. So very decent question, okay? Now, what about this one? So here you apply this rule here, right? So that is nothing but log e x squared plus 3, right? And you're going to put half here. Why half? Because you have to put 2 here, then only you are fulfilling f dash x, right? And then you are going to, multiply by half there. I hope you understand what I'm saying here, right? Then minus 3. Okay, I will do it separately. So here, integration 1 divided by x squared plus 3. So what I'm going to do is, I'm going to introduce square root 3 here and x squared plus 3 here and divide by square root 3 here. Then when I do that, this would be tan inverse x divided by square root 3. Okay, so you have to do it very carefully. Then we will compile everything here. We will compile everything here. So 1 divided by 12 log e x minus 1 minus 1 divided by 6 log e x plus 1. And then here you have plus 1 divided by 24. Why? Because 12 times 2 is 24 log e x squared plus 3. And then you have another 3 here, right? So that 3 should come here and that 3 should come here. So it's going to be square root 3. So, and that's minus square root 3 divided by 12, because this 12 is counting here, right? Tan inverse x divided by square root 3. Okay. So, yeah, plus k, and that would be the answer.